Welcome to the Proton Ideas channel. From space, our home looks serene. 70% of the surface is covered in deep, tranquil water. But that peaceful exterior hides a violent, restless engine. This cross-section shows the hidden mechanics of our tides. Because the Earth is spinning rapidly and the Moon's gravity pulls from the outside, the oceans bulge out on both sides. This creates a giant centrifuge of water, constantly dragging against the continents twice a day. By zooming in on where that water meets the land, we can observe the sheer physical stress involved. The belly of the incoming wave drags across the seafloor, generating enormous friction, grinding away at the rock face with relentless kinetic energy. You can see the results of that friction off the southern Australian coast. These 45-meter limestone columns, known as the 12 Apostles, are chipped away by about 2 centimeters every year. Eventually, the immense weight of the ocean will collapse them completely. And the oceans are not the only mechanism applying pressure. Every year, about 1 meter of rain falls across the planet's surface. That is enough physical water to fill the entire Empire State Building 500,000 times over, placing a staggering amount of weight onto the landscape. You are listening to us from Proton Ideas. Today, as global temperatures rise, the oceans absorb that heat and grow fiercer. Plunging atmospheric pressures generate massive storm surges, shredding human coastlines in a matter of hours. With this level of destructive force, we have to look closely at how biology manages to survive here at all. The tidal zone represents one of the most hostile environments on Earth, an arena where pure kinetic energy smashes directly into solid resistance and relentlessly churning anything caught in between. This diagram shows how certain creatures turn that hostility into an advantage. As offshore winds slam into the cliffs, the air is deflected violently upward. Australian pelicans, weighing up to 7 kilos, use that exact updraft to carry their massive frames effortlessly above the surf. Gulls face a different mechanical problem, existing in an environment saturated with water that is entirely undrinkable. To cope, they developed specialized glands above their eyes that filter out the heavy salt and expel it through their nostrils, operating as self-contained desalination plants. Below the surface, the rising tide stirs up a thick mud, dropping visibility to 0. Bottlenose dolphins navigate this dark soup by projecting high-frequency squeaks and clicks from their foreheads, listening for returning echoes to hunt down tiny prey in the chaos. These animals endure the crushing waves and blinding silt because the rewards are rich. The turning tide rips nutrients off the land and pulls organic matter from the deep, creating a highly concentrated food web available only to those built to withstand the physical pressure. You are listening to us from Proton Ideas. Inland, water behaves differently. Instead of a constant, grinding tide, sudden drops in atmospheric heat and pressure can trigger heavy clouds to burst, dumping massive volumes of liquid in catastrophic spikes. When this hits a sun-baked, unyielding landscape, the runoff gathers instantly. A flash flood can push more than 5 meters of water through a dry basin in under 6 hours. The rising water acts indiscriminately. It flushes burrowing insect colonies completely out of the earth and effortlessly overwhelms large-scale human infrastructure, causing billions in damage as rivers simply bypass their banks. But in the Sonoran Desert, these violent, short-lived monsoons are the only way the local biology sustains itself. Summer winds drag Pacific moisture inland, dropping heavy rain with sudden ferocity onto a landscape designed specifically to hoard it. The moment the flood seeps into the low valleys, the arid environment explodes into a rare period of abundance. Invertebrates and heavy mammals alike rush in to drink and feed before the intense sun bakes the earth dry again. On a planetary scale, this destructive surge is highly efficient. The moving water acts as a massive conveyor belt, ripping rich silt and organic nutrients down from the highlands and depositing them directly onto the barren soils below. In the Amazon basin, the inundation is not a sudden spike, but a sprawling, cyclical event. When the rainy season hits the highlands, runoff swells the region, raising water levels by over 12 meters and completely swallowing millions of square kilometers of dense forest. This forces a complete inversion of the ecosystem. The high canopy, usually reserved for birds, suddenly becomes accessible to heavy aquatic grazers. Manatees and river dolphins easily swim through the treetops to feed on submerged fruits and flush out hidden prey. Other regions adapt by pulling water directly out of the sky. In the Smoky Mountains, heavy rain is less common, but the forest stays permanently drenched by actively harvesting atmospheric fog drifting inland from the Atlantic coast. The local plants release tiny, volatile organic aerosols from their leaves that physically attract airborne moisture. The trees construct their own low-hanging clouds, dragging the mist down so it seeps deep into the earth, actively recharging vast underground aquifers tapped by 30 million people. Whether it arrives as a crushing river surge or a silent pulling mist, water physically dictates the architecture of every biome, forcing the biology within it to conform to its strict parameters. You are listening to us from Proton.Ideas. Because this resource is both vital and incredibly volatile, the pursuit of it drives the largest terrestrial movements on Earth. Over 1.5 million wildebeest march in a continuous 40,000-kilometer circle across the Serengeti. They strictly track shifting rain clouds, migrating into predator-dense territory just to secure fresh grass and drinking water before the plains dry up. Today, as human activity accelerates atmospheric warming, the cycle of evaporation and precipitation is becoming dangerously amplified. Clouds are taking on more weight, and the resulting weather systems are pushing far past their historical limits. To survive, we have to look to the natural world. Wildlife endures by reading the environment and adapting to it. Our equivalent is science. By predicting massive weather systems, we can engineer better defenses and take calculated, evasive action before a storm makes landfall. Water will forever dictate the rules of the blue planet, but understanding its immense power is the only way we can endure it. Thank you very much for watching the video. If you have not subscribed to our channel, be sure to subscribe and set the bell icon to the all option so that if we upload a new video, a notification will come to you and you will be informed. Please don't forget to like and give us energy with your beautiful comments, and send this video to your loved ones so we can be seen more.